Let's continue to explore the derivatives of trigonometric functions. Let's start by deriving the derivative of the sine function. So before we actually start finding that derivative, we need to recall a couple important trig limits that we completed in the last chapter. So recall that the trig identity, and the other thing is we need to also remember this trig identity for the sum of angles formula that we learned back in our trigonometry class. So these are the things we need to remember. This, and this. And these are going to be helpful parts for going through and finding the derivative of the sine function. Okay, so let's see. If I started this, we're figuring out what is the derivative of the sine of x. So let's do it the long way because we don't have our derivative formula yet. And so I'm going to show you how to derive this the long way and where this proof comes from. And I'm not going to do it for all the other ones because they're all pretty similar, but I will do it for sine because it's important that you kind of see where these come from. So if we go back to our basic definition of a derivative, we learned it's the limit as h approaches 0 of the function evaluated at x plus h. I'll just write that out, this whole thing out, of f of x plus h minus f of x all over h. So that's going to become the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. All right, so this is where this trig identity comes into play. The limit as h approaches 0, so I'm going to change the sine of x plus h into the sine of x times the cosine of h plus the cosine of x times the sine of h minus the sine of x all over h. Okay, so what I can see here is this becomes the limit, and I'm just going to do some fancy math to get it into these ways that we can actually simplify. So notice this term has the sine of x, and this term has the sine of x. So I'm going to rewrite this so you can kind of see what I'm doing. I'm going to move the sine of x over. So all I did is I flip-flopped the order that these were written in, which I can do. Okay, so what I'm going to do is I'm going to factor out, again, both of these terms have a sine of x in them. So I'm going to factor that out. So that's going to be the sine of x times the cosine of h minus 1 plus the cosine of x times the sine of h, and then this is all over h. Now you could be wondering, why am I doing this? Well, that's where these limits that we've already come up with in the last chapter are going to come into play. So I can rewrite this as two limits. I can write it as the limit as h approaches 0 of the sine of x times the cosine of h minus 1 all over h plus the cosine of x times the sine of h all over h. Okay, I can rewrite these as follows. So this first part is the same thing as the sine of x. We should probably do this. We're taking the limit of this whole thing. So this is the same thing as the sine of x times the cosine of h minus 1 all over h. I'm actually going to distribute this limit through as well. So plus the limit as h approaches 0 of cosine of x times the sine of h over h. Because those just have those x's in there, I can pull those in front of the limit because I'm looking at what happens as h approaches 0, so that is always going to stay as cosine of x. And then I can pull this cosine of x out because, again, it doesn't involve the h. I'm just looking at what happens with the h values. And then that's where these two functions come in. So I get the sine of x times 0 because of this, plus the cosine of x times 1, which is just the sine of x, or the cosine of x. So I can actually say we've derived the derivative formula for this. So the derivative of the sine function is the cosine function. Let's look at this graphically. So you can see here, I'm going to move this point. This is on, the black is the sine function. I'm going to move it over, and you're going to be able to see what happens. So this line is the slope of the tangent, and what's getting graphed in blue is what that value is. So it's the derivative graph. So here comes that derivative graph. It's changing color just because it's showing that here it's decreasing. Increasing, decreasing. And you can see if this down below, that is what the cosine graph looks like, and you can see that is exactly what was graphed here. So you can see where that cosine graph comes from the derivative of this sine graph. All right, derivatives of trigonometric functions. So we just showed that the derivative of sine of x is cosine of x. You can go through those same steps to figure out what the derivative of cosine of x is, and that is negative sine of x. Now, once we know the derivative of sine and cosine, we can find the derivative of the rest of these four functions. And I'll show you the proof for one of them, and then you can do the rest of them out on your own if you'd like to. But we can do that knowing that these, like for example, the tangent function is sine over cosine. The cosecant function is 1 over sine. The secant function is 1 over cosine. And the cotangent function is 1 over tangent, or you could say cosine over sine. So once we have one of them, or these sine and cosine, we can figure out the derivatives to the other. And again, I'm going to walk us through those steps on the next slide, but I'll tell you right now, just so you have this all in your notes in one spot, what these derivatives are. So the derivative of the tangent function is secant squared x. The derivative of the cosecant function is negative cosecant x, cotangent x. The derivative of the secant function is secant x tan x, so secant of x times the tangent of x. And the derivative of the cotangent function is negative cosecant squared. All right. Okay, so let's find the derivative of the tangent function by a proof. So we know the derivative of tangent is secant squared of x, but I want to just show you where that comes from. So if we were to do this, d over dx of tan of x, so that's going to be the same thing as the derivative of sine divided by cosine. So at this point, we can use that quotient rule to evaluate this. So that's the derivative of the denominator, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over cosine squared x. So the denominator squared. Okay, so this gives us cosine of x. The derivative of sine of x is cosine of x minus sine of x. The derivative of cosine of x is negative sine of x. And then again, that's all over cosine squared of x. So this becomes cosine squared x plus, because minus times a negative is turns that into a positive, so plus sine squared x all over cosine squared x. Now, in trigonometry, we learned a trig identity that said cosine squared plus sine squared equals 1. So I can replace this numerator with 1. So I get 1 over cosine squared x, which becomes 1 over, and cosine squared x is secant, so that just becomes, 1 over cosine of x equals secant of x, so this just becomes the secant squared x. So again, 1 over cosine is secant. So that's how I can replace that with there. So you can use this same exact strategy if you ever needed to prove the derivative of the cotangent of x, the derivative of the secant, and the derivative of the cosecant.